Like I said, circles is what we're looking at. And this question says two chords PQ and RS of a circle intersected at right angles at a point inside the circle. If QPR is 35, find PQS. We're able to draw a circle now. We put chord PQ in white and RS in white intersecting at that right angle. Is that clear? Okay. Are you hearing me? Can you
I'm
hear me?
hearing you, sir.
Okay, okay.
Yes, sir.
All right. So we are able to identify angle uh, QPS as P in this triangle. QPS. I mean QPR rather. QPR. So that is the one that has a 35 is the letter P. Okay. And that is angle P, not the three angles, because these are three angles, but the one at the middle is what we are referring to. So the answer find angle PQS. Now from P to Q to S, P to Q and to S. So the one at the middle again is what we're looking for. That's why I'm asking Moses to say whether your explanation, I said, how did you get 55? Which I confirmed that 55 is the answer. But that's why I'm just explaining so that you can get a better understanding. There is a principle here that's going to hold. If you see, I want to introduce another chord. Look at this blue line. Let me see. I want to introduce a blue. Can you see this blue line?
Yes, sir.
Now, this blue line is a chord that subtends two angles at the circumference. It's a chord that subtends two angles at the circumference. So if I introduce the other side of PQS, which is this side, okay? Is that clear? Can you see this?
Yes.
So that means
Yes.
the angle we are looking for is not the totality of that question mark, it's just a portion of it that makes a triangle with the PQS given to find, okay? So we're going to join that together to actually see the portion we are looking for. Is that clear?
Yes, sir.
So if I join the line that I want to join, if I join it, let me join it with a brown line now. So from Q to S, okay? So if I want to identify the angle I'm looking for, it will be the whole of this region, okay? This brown region. But there's a principle or a theorem that states that angles subtended or angles in the same segment are equal. Okay.
That's
What did
good.
I call it?
Having the same segment and equal.
So which angles can you find in the same segment now? And how are you sure they are in the same segment? Which angles can you find in the same segment and how are you sure they're in the same segment? The angle at this spot R and this spot Q, they are in the same segment because they are subtended by the same chord, the blue chord PS, okay? Can you hear me?
Yes, sir.
They are subtended by the same chord PS. The line PS is the one that carries the first triangle, which is the first angle at Q. Then the line PS is the same line that carries uh, angle at R. So if I can use that 180 stuff in a triangle to find the one at R, then the value of R equals to the one at Q. So if this is a theory question, what you'll be expected to do is to draw this triangle, I mean, the circle and the triangles inside it this way. To identify those angles, then you will write the theory out or the theorem out that angle R equal to angle Q. Or better still, you can say PRS, okay, equal to PQS. And you remember it's PQS we're looking for, right? Right?
Yes.
So, what is the reason for this statement that PRS equals to PQS? The reason is that angles in, yeah, in the same segments are equal, okay? Don't forget that. How do you identify angles in the same segment? Let me show you something. If you have a chord, let's say this chord, this red chord, okay? If that particular chord subtends various angles, there are two segments now, yes or no? This segment,
Yes.
this segment, and this segment, right?
Mm.
Okay, the major and the minor segments.
So,
So if that chord you are looking at should subtend an angle at this spot, you know, it subtend this angle. Wait a minute. So if it subtends this angle, and the same chord still subtend another angle, provided that it's touching the circumference. Are you listening?
yes, sir.
Uh-huh.
Yes.
Provided that it's touching the circumference this way, this is another angle, right? So these two angles that are the circumference must be equal. Even if it's going to subtend another one, it may be this place, okay? Provided they all have the same base on that red chord. Let me label the chord maybe AB, okay? So if the angle at this spot is angle A, the angle here is angle B, the angle here is angle C. Are you getting that? We can say A equal to B equal to C. Is that clear? You are muted, so I can't even hear you.
Yes, sir. We are hearing you.
Okay, I'm trying to see whether you get the explanation. So, even if it obtains yet another angle, maybe at this spot, the same is carrying another angle up,
Moses.
and
Okay.
yet, are you sure you are concentrating or you are distracted? And yet, maybe another angle at this place, you know, no matter where they come from or where they pass through, in as much as they are from the same base, AB, all of them are equal, and in as much as they are all touching the circumference, if they stop at the center, that angle is not part of them. Okay?
Yes, sir.
So if this one is angle D and this place is angle E. So we can say A equals to B equals to C is the same thing as D and is the same thing as E. But let us now try to locate other angles that share the same base with that chord, okay? Picture this angle at the center, this one. It cannot be equal with those other ones. Picture this one, it won't be equal with them. Picture this one. You can see there are other angles there at the middle, right? Having the same base. Is that clear? So those angles are not what we're talking about. Okay? But the ones we are referring to, I'm not sure you can hear me, maybe it's network stuff there or something. So let me know if you can hear me. Okay, so I just continue now. But so all this angle, the portions in black, they are the ones that are equal. And why are they all equal? This is because they have the same base. They are subtended or carried by the same chord. So back to the question we were given. Can you hear me now? You're muted right now.
Yes, sir.
Okay, good, good. So back to the question we were given. We need to find the angle at R based on what Moses did, which is um, R plus P. Angle at R plus angle at P is 90. Since it's in a triangle, that's a right angle. So angle at R plus angle at P is 90. So angle at R will be 90 minus 35, which is 55. And that angle at R is what we call PRS. Is that clear? Which is now equal to PQS that we're looking for. And that is where the 55-degree came from. Is this clear to you?
Yes, sir.
See all these angles I marked with white at the center. They are not part of the angles we're talking about that are equal, okay? I now mark them in yellow. They are not part of those angles. But the ones at the circumference are the ones that the theorem holds for, okay? Is that clear?
Yes, sir.
So, oh, no, I don't need to do that. So let's take note of that. I'm going to bring the next question, but I just feel I should do justice to that because you can find any question that relates with that particular, theory or theorem, and you should hence be able to do it. Just hold on a bit. So, based on the question that says the angle of a sector of a circle of diameter 8 is 135, find the area of sector. You've been given pi to be 22 over 7. The only thing, the basic thing you need for this question is to know your formula, okay?
From
Yeah. Area of sector is given by
yes.
theta
Theta over 360 times 2 pi. No, times pi r square.
times pi r square, okay? Is that clear? Can you hear me? Okay,
Yes,
good. So the theta you are
sir.
given is 135 and you have 360.
65.
Then the pi is 22 over 7. The radius is 4 because the diameter is 8, okay? Radius equals to
Yes, sir.
diameter over 2, which is 8 over 2, and that is 4. So we can say 4 times 4. So we can now start dividing and say 2 here is 11 and 2 here is 180. Then we can also say 2 here is 2 and 2 here is 90. 2 can still divide. 2 cancel 2, then we have 45. Now we have 5 here is 9 and 5 in 13 is 2. In 35 is 7. Okay, is that clear? Can you hear me?
Yes, sir.
Then 9 here 1,
Yes,
9 here 3. So what we have left now is 3, 11, and 4 at the top. So that is 33 times 4. 3 and 11, that's 33, then times 4, all over 7. So what is 33 times 4?
33.
Yeah, 33.
132. 132.
33 times 4. This is 12. This is also 132 over 7, right?
Yes, sir.
And 7 in
Yes.
this is 1, right? Remember 6. And 7 in this is 8, which is 56. So if you remove
Remember 6
56, you have 6 over 7. What's the unit?
centimeter.
No,
By r square. No,
no.
sorry, centimeter square.
Centimeter square, okay? Is that clear?
Yes, sir.
Okay, so we're going to look at the next one briefly. Let me see. Okay.
This mistake.
So looking at this question, it asks us to find angle QRS. Now, before we can talk about QRS, QRS needs to form a triangle somewhere here, okay?
Mm-hmm.
Like this. But it's not totally in that circle. It doesn't matter. Whenever you see a straight line touching a circle, think about tangent. Think about what?
Tangent.
And when you think about tangent, what you are only looking at is that the line is connected to the radius. Do you know what radius is? From the center to any part of the circumference is radius, okay?
Yes, sir.
So it could be from ear to ear, or this way, or this way, or this way. So any line that is from the center that is touching the circumference is your radius. So which of the radius or which of the radii is the tangent connected to? Is it PO or OQ or OR? Which of them is the tangent touching?
P O.
Wait, we have radius
OP.
we have radius at OP, we have radius at QR, we have radius at OR. Which one is the tangent touching? Do you know your ta-
Yes.
do you know your tangent? This is your
The
tangent.
line.
This line is your tangent. So which of the three radii that I showed you is the tangent touching?
OP.
Not OP. This is touching OR. Can you see O and R?
Yes.
Eh,
80. Oh.
OR, okay?
OR.
Good. So as it is touching OR, it means it makes 90 degree with OR. It does what?
Make 90 degree with OR.
With OR. So if I drop this blue line as our tangent, then I can say the angle it makes with the OR radius is 90. Okay.
Yes, sir.
So now, once we know that OR is a side of angle ORQ, triangle ORQ, and OQ is also a side, and they must be equal because this is a radius and this is a radius. Is that clear?
Yes, sir.
Then this is an isosceles triangle, okay?
Mm.
Which means the base angle must be what?
Equal.
Equal. So if the base angle are equal, what's the value of the angle that is part of this tangent stuff? We cut it into two. One part is at the top here, one part is at the bottom here, right? And the part at the bottom is what we're looking for, but the two of them must make 90, okay?
Mm.
So we can find this angle, yes or no, because they are equal. If you take 80 away from 180, you have 100. That means each of these should be 50 because they are equal, right?
Yes.
And once each of these equal 50, then I have been able to get what we are looking for to be 40. So what you're going to
Yes.
write down, if it's a theoretical question, you're going to write down that ORQ, ORQ, let me write it again, ORQ plus the one we're looking for, QRS, okay, equal to 90 degree. Why? You put tangent there, okay,
Yes, sir.
of a circle makes 90 degree with the radius, okay.
Yes, sir.
Now you now say, at least you need to find ORQ. You now say ORQ equal to OQR, okay. Why are they equal? Angles, base angle of an isosceles triangle, okay.
Yes, sir.
Base angles of an isosceles triangle.
Try.
Is that clear?
Yes, sir.
And with that, you don't need to show any working for anybody. With that, you can say the ORQ now is 50, since it's obvious, okay? ORQ equal to 50. But if you want to show the working further, you will just say angle at O plus angle at R plus angle at Q is 180 in a triangle. Then at O is 80. R and Q are equal. Call them X and X, okay? Then you have 2x equals to 1 on 180 minus 80, which is 2x equals to 100. X equal to what? 50. So that means the angle at the top here is 50, okay? Is that clear?
Yes,
So that
sir.
means ORQ plus whatever. So 50 plus the one we're looking for, QRS, equal to 90. So QRS will be what? 90 minus 50, which is
40.
40 degrees. That's clear, right?
Yes, sir.
Okay, so let's look at one more question that looks like this before we move to
Okay.
chemistry. Let's see. Okay, so this question. So, can you see this other question?
Mm.
Is Moses still there?
Yes, sir. It's here.
Because I'm not hearing his response. That's why I'm asking. Moses,
Moses.
hope all is well. Or you want to part the Red Sea? Hmm?
Hmm.
Hope all is well. Or you are sleeping. Did you go for vigil?
On your fish.
You went for vigil?
Hmm.
Okay. Oh. So I want to be hearing your response, at least so that I can know you are being carried along, not that you are just there. So look at this question. It says in the diagram, PQR is a circle with center O, then that is obvious. If angle OPQ is 48 degrees, find the value of M. This is this is like a straightforward question, okay?
Yes, sir.
Uh-huh. Why did I say it's a straightforward question? Look at this. This is a radius OP and OQ is also a radius, which makes the triangle isosceles, okay? So the angle at Q will also be 48. Is that clear?
Yes, sir.
Then we can find the angle at the center. Yes or no?
Yes,
So
sir.
let's say 48 plus 48. What is 48 plus 48? That's 96. So the angle POQ will be 180 minus 96. Is that clear?
Yes, sir.
So what is 180 minus 96?
84.
84.
84.
So that angle at the center is what? 84 degrees. Then we're looking for M. M plus 84 degrees equal to 180. Who can tell me why?
Angle in a triangle.
No, no, that's not the reason.
Angle in a segment.
Straight.
Angle on a straight line. Who said that one? That's correct.
Segment.
So angles, sum of angles on a straight line equal 180. So we can now say M equal to 180 minus 84, and that is going to be 96, right?
Mm.
Is this clear to you?
Yes,
Yes,
sir.
sir.
Okay.
Yes.
You're going to hold on a little bit while we switch over to chemistry, okay? Okay, so Moses, check this
Sir.
out. Check this one out.
Studio my drugs guy.
Okay. Sodium sodium hydroxide, right?
Yes, sir.
Did you know what the question is asking you, or you just pick one?
I just speak.
Okay, you just pick one. There is a particular term there that looks might look irrelevant, but it's actually the basis of the question. What is this thing I underlined, all of you?
Okay.
Fine chemical.
Fine chemical. So that is to inform us that we have two
FE.
types of chemicals, okay?
Yes, sir.
We have what?
Two
Two
types of
types, two
chemical.
major types. We have the fine chemicals and what?
Heavy chemicals.
Heavy chemicals. So if you must know this kind of question or you must be able to answer it in the exam, you need to know about fine chemicals and heavy chemicals. Okay.
Yes.
Now, fine chemicals are chemicals that are so sensitive that advanced drying techniques are often needed to preserve their essential qualities. Heavy chemicals often bypass this drying altogether, relying on production methods like distillation or whatever. So, now to differentiate between fine chemical and heavy chemical, like we can talk about the differences between them, okay? Number one is that heavy chemicals are large scale industrial chemicals produced in bulk quantities for applications such as fertilizers and detergents. You know, it, the use for fertilizer is very common because they will use it on the farm, right?
Yes, sir.
And that will be on a large scale production because you cannot say in a country only one person is the one farming, right? Like in a country, can you estimate the number of farmers in a country? Are they just about 10, or you can even see them in hundreds of thousands, right?
Yes,
So that
sir.
means if they are going to be needing chemicals, these fine chemicals, I mean the heavy chemicals that we're talking about, if they are going to be needing fertilizers, it's going to be in larger quantity, and the chemicals they use in producing it is going to also
Mhm.
be produced in larger quantities. So heavy chemicals are large scale industrial chemicals produced in bulk quantities for applications such as fertilizers and detergents. That's one. Then fine chemicals are produced in smaller quantities with higher purity level. They call them fine chemical because of the purity level. So if anything go wrong with their production, it can have devastating effects. And they are used in research and in pharmaceuticals, that is, in drug productions. Okay.
Yes, sir.
So the chemical that we can see that is like so toxic, that we can say to so toxic or so concentrated or so whatever here, is that option B, which is hydrochloric acid. Okay.
It's limits.
Is that clear?
Yes, sir.
Which side? So fine chemicals are complex, single, pure chemical substances produced in limited quantities. Heavy chemicals are produced and handled in large lots, large quantities, and are often incrusted. So some examples of heavy chemicals are the ammonia, sulfuric acid, sodium hydroxide. And an example of a fine chemical is the hydrochloric acid. So take note of that one. Yeah.
Yes, sir. H2SO4 is under what, sir?
H2SO4, that's an acid, right?
Ah,
Uh-huh. H2SO4 should be a fine chemical, okay? Because acids are not produced in large quantities like that, okay? Is that clear? Particularly, you can have concentrated acid, right? But
yes, sir.
if it is less, if like I mentioned, I said sulfuric acid is also the part of the H2SO4. Sulfuric acid is the SO4 family. Is that clear? So sulfuric acid, not all of them are heavy chemicals. Okay.
Okay.
So sulfuric acid, he said, is a fine chemical at the concentrated level. So let's go to the next question. Okay, they want you to name a particular compound. Okay, that is under organic chemistry. So just the basics of organic chemistry, naming compounds. So let me bring the options. The options I have here. So who is answering this?
Sarah, I don't understand. Nothing you understand. Why would I want to ask you?
So if you must understand this question, if you must be able to do it, you must study homologous series or you study the alkane, alkene, and alkynes in your organic chemistry, okay?
I'm saying I agree with you.
Alkanes, alkenes, and alkynes, okay? And you know that alkane is carbon to carbon single bond. This is carbon to carbon double bond, and this is carbon to carbon triple bond. So which
What's the
bond
number?
can you see here? You can see double bonds, right? There are
Yes.
two double bonds there. One double bond, another double bond. That is a di double bond, okay? That is why all of them, di of the alkene, diene. So that is why all of them are diene, 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 okay?
Yeah.
Is that clear?
That's tough.
Now, you want to name it, you can see chlorine there, right? Before you begin to name the parent, which is the alkene, you must mention the chlorine and you must count the chlorine. Firstly, count the double bond, then count the chlorine. The double bond here, the first one is after the first carbon, while the other one is after the third carbon. Okay?
Yes.
So we could have the double bond as 1, comma 3 diene. Okay? But
Yes.
let us consider the chlorine. If you count it from the right to left, you have 1, comma 3. If you count it from left to right also, it's after 1 and the third one. So that is still 1, comma 3. So we have no issue with the double bond. Okay? We
Yes.
have no issue with where to count our double bond from. But let us now check the chlorine. If you count from right to left, chlorine is number 3. So that would be 3 chloro.
Yes.
Okay?
Three.
Are you with
Yeah.
me?
Yes.
3 what? Chloro.
Mm.
1, 3. I mean, you must firstly know the parent, uh, the main hydrocarbon, which is 4. And C4 means boot, like methane, ethane, propane, butane, and so on. So C4 is a boot compound, okay? Butane. Is that clear? So for double bond, we have butene, okay?
Yes.
And for triple bond, it will be butane. So you need to study all of the homologous groups. So here now we have 3 chloro, uh, but
It's
1, 3 diene, okay? 3 chloro, but 1, 3 diene.
fine.
But we are not done. Let us now look at the other way around to count the chlorine. If you count it from right to left, back to left, we will have two chloro, yes or no? As in on the second carbon, one, two. Are you getting that?
Yes.
That's where the chlorine is. So two chloro, the same but one three diene, okay?
Mm.
Now if you check these two, the two of them are in the options, right?
Yes, sir.
So two chloro but one three diene, three chloro but one three diene.
Mm.
We will go for the smallest number. So which one is our answer?
Two chlorobrook, one three
3 diene.
diene.
That is the option A. Okay. Is that clear?
Yes, sir.
Go for the one that if you had 3 plus 3 plus 1, it give us 7. 2 plus 1 plus 3 give us 6. So the smallest value is what we pick. Okay.
Yes, sir.
All right. So let's go to the next question. Um, the next one. Which of the following Which of the following substances is a polypeptide? Have you heard anything about polypeptide before? Yes? Anybody?
So what's polypeptide?
That is what I'm
So I
asking
think
you. I said, have you heard anything about polypeptide before?
before. So I think protein.
Okay. Somebody said starch or protein, while somebody said protein. It's actually protein. Peptide bonds are found in protein, okay?
Yes,
Peptide bonds. So whether you're now saying uh, polypeptide, like they're found in amino acid, okay? And proteins are polymers of amino acid. Is that clear?
sir.
Okay, then the next question asks say which of the following product, let's see.
Oh,
So which of the following products could be formed using incomplete combustion of a hydrocarbon? Yes,
so I think carbon and carbon dioxide.
carbon and carbon dioxide, right? That is option 1 and 3, right?
Yeah, I think so.
Hmm. It's correct. Incomplete combustion occurs when the supply of air or oxygen is poor. Water is still produced, but carbon monoxide and carbon, it's carbon monoxide, okay? So carbon monoxide and carbon are produced instead of carbon dioxide. That would be carbon dioxide.
No,
Carbon dioxide is carbon dioxide, but
no,
this is carbon
no.
2 oxide, okay?
No.
Is that clear?
Yeah, depends, sir.
Carbon 2 oxide and carbon. Then the carbon is released as a soot. Okay, let's look at this next question. So this one says, What quantity of electrons is lost when 1 mole of iron,
Iron 2, iron
ion 2 ions is oxidized to ion 3 ions? So let me bring the options there. Yes. Which option do you go for?
what quantity of electron is lost when 1 mole of iron 2 iron and that's iron 3? It's 2 mole. Yeah, I feel it's 3 moles. I know it's 3 moles. So I mean, I picked 2. I picked 2.
Ion 2 to ion 3, right?
Yes.
Hold on. From
A
Fe2
mole
plus
to Fe3.
Fe3 plus. Um, if it must become Fe3 plus, it must lose an electron, right?
Yes.
So that will be
Oh,
that will be 1 mole. Okay. Because if it lose one more electron, then it goes to 3 plus. Is that clear? Is
so if
that?
it's losing when um iron 2
Mm-hmm. You are saying something?
so when iron 2 is using 1 electron, it's
Mm-hmm.
going to the other side.
Mm-hmm.
So it's not when it's going to the other side. That means one will be if okay, now this 2 plus now
Mm.
represents giving out, that is negative. It
Mm-hmm.
loses
That
giving
is,
out.
it's going to lose one electron.
Yes.
You understand me?
Mm.
When it loses an electron, here at this state means ready to give 2 electron, right?
Yes.
And that is the uh, oxidation state. Okay. Now, if it lose one electron from the pale green ion 2 oxidized to I think brown ion 3 or so, it lose an electron, then it become 3 plus. So when an element lose electron, that's when it become positive, more positive, okay? But when it gain an electron, it becomes more of negative because number of electron decreasing means number of proton increasing, okay?
Yes.
So let's take note of that one. Then we can look at one more question before we round up for today. Then we're going to meet tomorrow by the grace of God. So let me see this next one.
What do you want to do now? It's now.
So the next one says, so what is the mass of silver deposited when this amount of electricity is passed through a solution of silver salt? Given 1 farad equals to this, and atomic mass of silver is 108. So let's look at this together.
Well,
The silver, silver plus one electron because of the charge on it will give us, that is silver plus, okay? Silver plus one electron will give us the silver neutral. So it is 1 mole. 1 mole is
Sir,
1 mole of silver.
sir,
Yes,
Mr. Ajibala,
yes.
is there not meant to be a negative ion on the E?
You mean on the electron, right?
Yes.
E is always electron, so nobody will mistake it that it has negative or it doesn't have negative. Okay. So now 1 mole of silver is 108 according to this information. Then the 1 farad, what it's going to produce will be, if 1 farad is that is when we say for one, but for 1 farad it will be 96,500. Is that clear? Times 108. So for one complete mole, that will be 1 farad given is 96,500. So what will be produced will be 108 times 1,
And then,
which is the 1 mole. 108 times 1 mole times 96,500.
500.
So, but okay, let's try to get what this one is going to give us. We have 108,
Plus 10.
96, 500. So this gives us 10,422,000. Okay,
Yes.
422,000 for this is the charge that we were given, which is 24,125, will produce that charge times the atomic mass, which is 108, that charge, which is 24,125, times the atomic mass, then divided by the charge for 1 mole, which is 96,500. So let's try it. 24,125 times 108 divided by 96,500.
Remember, you said
Okay, so are you okay?
96,500. So that will be 27 grams, okay?
yes.
Is that clear?
Yes,
So
sir.
that will be 27 grams. And that's where we'll be rounding up for today. By God's grace, we're going to meet tomorrow. So let me